You know how you do 1.
If this wasn't 1.
Yeah. Then would you times it down here, like let's say it was 2, would you go 1.5 times 2?
Which would be 3, which would be 3 inches, and then you just put a 3 here and a 3 here.
Right, okay.
Exactly, my
So
friend,
you just,
exactly,
okay.
exactly. Now, geometrically, that's the algebra. Actually, it's arithmetic, but that's the math behind what's going on. Visually, here's what's going on. What the TI does, or what this method does, is it takes the IQR like this. Okay, with me so far? That's 1 inch. It increases that by 50%. That's 1.5 inches. It takes that, puts it on Q3, and it says, okay, right out here, that's the right bound for typical data. Anything further right than that is too big to be typical. Is anything further right than that?
Yeah.
No, that's the biggest value, and it's left of this, so it's not too far that way. Fair so far? Now do the same thing on this side. There's 1 IQR. Here's a half added onto it, so now we're here. Stack that on Q1. There. Those 2 squiggly lines. If you're looking for an analogy, those 2 squiggly lines are basically the same thing as this guy right here. Same logic applies. Anything outside of those lines, either too big or too small. Is anything too small?
Yes.
There's at least one thing that's too small. And there might be more, because we can't tell what. Right, we can't tell if there are any 69s, can we? There might be a data point right here, but we can't identify it. All we know is there are a number of data points in this whisker, exactly 25% of the class, which is like 4 people, because this is a pretty small class. So there's 4 dots in that, on that whisker somewhere. We know the leftmost one is too small, but there might be more than that one. This is where the modified box plot comes in, friends. Go ahead.
But I have a question.
Yeah, go ahead.
Example. Can I show?
Yeah, go ahead.
You said we take this, then
half of it.
but then you started with this, not with that one.
That's the definition. You go 1.5 below Q1.
I see.
That's
Okay.
just, and again,
Okay.
it's a definition.
Okay.
It's not a law. It's not a postulate. It's not an axiom. It's not a corollary. It's not a theorem.
But then it
definition.
explains why the government.
It's like calling this plaid. We call this plaid because somebody called it plaid, not because it has to be plaid.
But that's
Sorry to all
why.
the Scottish people in here. But it's called plaid because it's called plaid. Somebody defined it as plaid. Brunette.
Okay. But
Wow.
1.5, you said that, I mean, like, yeah, 1.5, you can take
3,
or
2,
That's
yes.
why they manipulate.
Well, you can. And from what I remember in my study of this so far, anything outside of 1.5 is called a mild outlier. But if you change it to 3, anything outside of that is called extreme. That gets ridiculous. It gets ridiculous. I mean, if you're in the kind of industry that needs to deal with that, you'll learn it when you need to deal with it. Right now, I like this. It's pretty straightforward. And watch this. Watch this. Go back to your stat plotter. Go back to your box plot. Go back to your box plot, which is mine's in plot 2. And change the plot type from just box plot, which is this 5th choice here. Change it to the modified, which is this next one right here, next to it. And you'll notice you get another little option down here called mark. The mark is which symbol you will use to show the outliers if there are any. Now just press graph. And there it is. And notice, where'd the whisker go? There's no whisker anymore. Why? Go ahead, Mimi. Be brave, my friend.
Because the whisker was only pointing towards that outlier.
The whisker was only connecting the outlier back to Q1. Remember, I think there was either 1 or 2 guesses of 68. The next guess up was 71. So, because of the percentage and the class being so small, all the whisker was doing was connecting the very unusual 68 back to the 71, which was Q1. There are so many 71s in the data set that they're just all kind of stuck on that one little spot in the graph. It gets more interesting with larger data sets, I promise. But it's very cool data. I love this data set because of this. Because many cool, goofy kind of things happen. Yeah?
So when you trace it,
Yes, ma'am. You will see. Go ahead and hit trace. This is a great point. I'm going to erase this. So notice it doesn't give you the range values. It doesn't give you the range values, but you can figure those out pretty quickly based off of this. Okay, so when you hit trace and I bump up, right now I'm on x equals 71. You see that?
What's x?
Good question. Trace to the right, you'll see Q1.
Yeah.
Then you'll see
The median.
the median. Then you'll see 72, Q3, then the max. Trace back, Q3, median, 71. What do you think X is? What do you think X is? You tell me what you think it is. Hey, Deej, what do you think? Haley asked a fantastic question. What is the X? It just says X. And then, if you go further, it lies on min X equals 68. Now, that is the smallest data value, but it's also, it's not using X the way we use X. Well, when we just put X, it's a data point. And it is a data point.
Is it the math?
The average?
It's like the average X or something.
You guys are damn close. Go ahead, Trev.
I don't know, it's probably the same thing, the lowest value, that's not the outlier.
It's the lowest value in the data set that's not an outlier. So in other words, if you actually, let's try something. Let's try something, okay? Everybody go into your stat editor. And actually 2 folks guessed 68. I think I remember this. Put a 69 in there.
Another.
Wait, will that do it?
What, one?
That'll be an outlier 2, maybe. Actually, you know what? No, put a 70 in there. Put a 70 in. Take the 69 back out and put a 70 in. Is that fair? And let's just press graph again. There. Now you've got a whisker because you have a non-outlier data point that's in the bottom 25%. Now press trace. See the X is now? It says X equals 70. It's the smallest data point that's not considered an outlier by this definition.
Okay.
Fantastic question, a fantastic explanation, Trev. So that's exactly what it is. And you can have more than one outlier. You may have a series of them in a row. I showed my Math 105 results last class. Remember how I did hit the box of whisker plot for you guys and the histogram of your exam scores? Theirs went like this. It was reminiscent of that damn Math 95 exam from like 6 years ago. I'm like, holy crap. Only because 6 people were out of town on some kind of a trip for ASTOCC, and there were a bunch of zeros in there that were dragging things down. But the zeros plus the 5s plus the 6s plus the 7s, I had a string of outliers across the bottom, which happens. You can have a bunch of unusual data values. You just can't have super amounts of them. Otherwise, if you've got so many outliers, well, I shouldn't say that. You actually can have that. But if you have a ton of outliers, if half of your data set is being called outliers, you better recalculate what you're calling what you're calling the center, right? Because if half of your data set is outliers, that means your median's an outlier. It doesn't make any sense at all. You can't really have that. I mean, I'm sure you could try to make a data set that's close to that, but it doesn't make any sense. So you can have more than one, I guess is my point. You don't have to have just one. And the data set doesn't have to have any. You might not have any, right? I mean, if everybody here guessed from 71 to 73, we got a beautifully tight bell curve. Everybody's within 2 standard deviations. Hell yeah. Cool? All right. Now, that's pretty much the only 2 ways I want to talk about. Now, there are many other ways, including one we'll get to, thinking like next week sometime. But it has to do with probability. But what I want you guys to do, and we're just about at that break time, I got a little in-class quiz for us to do. It's just kind of like last time. I gave the in-class quiz to Amber to grade from last time, so you guys get that back next week. That was the snowfall data, when you figured out the unusual snowfalls. So this, there you go. You can work with somebody else if you want to on this, or work alone, that's fine too. Grab a copy. Basically, it's a bunch of data. I'm going to ask you to represent the data graphically with a histogram. You decide, bell-shaped enough? Okay.
Are we working
You can work together if you want. You can also do it individually. That's fine too.
one sheet or?
If you do it together, just do one. Yeah, that's fine too, if you just get to do it together. And then I basically have you practice both methods of outlier recognition on this. So again, especially this one right here, this one is not inherently obvious, because it's a weird definition. So we got extra copies. Awesome, Jenny. Thank you, my friend. So we're going to hit the camera, pause it for a little while.